Today is Wednesday, September the 2nd. Today in pre-calculus, we started section 2.2, which talks about polynomial functions. When you're looking at a polynomial function, the functions we've looked at so far, the constant function, the linear function, and the quadratic function are all examples of polynomial functions. But then we get to something a little bit bigger, so I'll go and share the whiteboard and show you what we did today with polynomial functions. Okay, a polynomial function is a function of the form f of x equals some constant multiplier, say like 3 times a variable x to a power, let's say the 4th power, plus some other one, 2x to the 3rd, and on down. So the powers all get smaller. So let's say x squared minus 3x plus 2. Now, so this would be a 4th degree polynomial because the highest power is 4. So it would be a 4th degree polynomial, 4th degree. And the 4th degree means it would have at most 4 real roots. So real roots would be less than or equal to 4. Real roots. And turning points. Real roots would be less than or equal to 4. And turning points would be or bins. Turning points would be less than or equal to 3, which would be 1 less than the number of possible real roots. Now, so if you look at this polynomial function we have here in front of us, the first thing we start with is we look at the y-intercept. Now, if you notice, the y-intercept in this case, the y-intercept is always whatever this number here is at the end, and in this case it's a 2. So the y-intercept would be here at 0 and 2. Now, we look at end behavior. This is a 4th degree polynomial. So when I go off to the left here to minus infinity, I take a negative number and raise it to an even power. It's positive. So the end behavior here, as x goes to minus infinity, this function would go off to plus infinity. In the positive direction over here, any number, any positive number to a power, to any power would be positive. So I know that this polynomial function starts up here in the 2nd quadrant. It goes through 0, 2, and it goes up into the 1st quadrant. Now, as I said before, it could have several intercepts. Like we could have, since it's a 4th degree, we could have an intercept here, we can have an intercept here, and we can find these using the calculator. We can have an intercept here, and we could have an intercept here. So we can have a curve that comes down like this, look, and comes back up and goes through 0, 2, and goes through here and goes like that. So need to be able to look at the equation of the polynomial and tell, number one, where its y-intercept is, number two, what it looks like its endpoint behavior, and then number 3 and 4, how many roots does it have? In this case, it's got less than or equal to 4. I drew one with 4, and it's got 3 turning points. So you see, here's a turning point right here. See, there's a turning point, and then there's a turning point, and then there's a turning point. Okay. So now, what we will look at tomorrow, we'll look at something called multiplicity, and what happens there is, what does your graph look like when you have repeated roots? Like if I have x squared or if I have x cubed, what does that part of the graph look like? So take a look at the problems that you have for homework tonight. And if you have a question about how those work, give me an email or send me an email and I'll get back to you.